Here we go, lesson 2, factoring review, everybody's favorite. Factoring review. So, a couple things to note. You gotta check for the greatest common factor and then factor further if possible. Now there's lots of different ways. There's inspection, there's factor by grouping. You might have found some other methods in 20-2, 20-1. We'll do it a couple different ways, and hopefully you guys remember how to do this. All right, so the first one here, we've got to check GCF. Now 5 and 30, 5x and 30. Now 30 I know is the same as 5 times 6. So what I can really do here is divide each thing by 5, and I can remove 5, and I get 5 and x plus 6. Okay. So that's as far as I can go. The second one here, I see 4m squared and 14m. Now it has m in common. 14 is not divisible by 4, but it's divisible by 2. So I can factor out 2m, and I'm left with 2m minus 7. So if you were to reverse the process, 2m times 2m gives me 4m squared, and 2m times negative 7 gives me negative 14m. All right, 3n squared minus 27n plus 60. I see that everything's divisible by 3 here. So let's start by factoring out a 3. So we get n squared minus 9n plus 20. And then I'm looking at n squared minus 9n plus 20. Oh my goodness, all right. So the first set of brackets, I know it has to be n and n. The only way to get n squared is n times n, all right? Then the last way, 20, could be 1 times 20, it could be 2 times 10, it could be 4 and 5. Now I have to kind of think, how do I get 9? All right, well the only way to kind of get 9 between those two options is 4 and 5. So it's got to be 4 and 5. And the end has to be positive, and the middle term here, negative 9n, has to be negative. So I'm going to make both of them negative because when you expand, that's how you get a negative middle term and a positive last term. All right, negative 4t squared minus 16t plus 128. All right, even if there wasn't this 4 here and it was just negative t squared, get rid of the negative. All right, you at least need to get rid of that. But all of these are divisible by 4. So let's factor out negative 4, and we're going to be left with t squared plus 4t. And not going to lie, I had to do this on the calculator. 128 divided by 4 is 32. So then I know that there's only one way to get t squared, and it's going to be t and t. And 32, we kind of have to add up to 8. So if you think through 132, 216, 8 and 4, probably missing another one here, but it's got to be 8 and 4. All right, there's no other way to get positive 4 with one of these sets of numbers. So it's got to be 8 and 4. How do I get positive 8? Make that positive. How do I get positive 4? Is to make the bigger one positive and the smaller one negative. And there we go. Okay, this one's written in reverse order, so just rewrite it. All right, there's only one way to get d squared, d times d, and 24 needs to be 8 and 3. Again, you could do 1 and 24, 2 and 12, 6 and 4, and 8 and 3, but the only way to get a difference of 5 is going to be 8 and 3. So we need it to be more negative, so make the 8 negative and the 3 positive. This one again is written in reverse order. All right, I see a GCF. They're all divisible by 5. So let's factor out that 5 first. and this one has to be C and C. It's got to be 5, and it's got to be, sorry, it's not got to be 5. How do I multiply to get to 6? 1 times 6, 2 times 3. The only way to add to 5 is going to be that 2 and 3. So 2 and 3. Not 6 and 1. Okay, 3b squared minus 13b minus 10. All right. They are not divisible by 3. So we're kind of stuck trying to figure this one out. Well, at least there's only one way to get 3b squared, and that's going to be 3b multiplied by b. So we can start there. All right, and we need to figure out how to get this middle 13b, but also multiplying to 10. So ways to get 10, 1 times 10 and 2 times 5. All right, so if I put 1 and 10 there, and I multiply this, I get 3b and 10b. Okay, could work. But if I make them both one positive and one negative, which you have to, because the when you multiply your first and your last number here, I want it to end up being negative. All right, and the only way to do that is to make one positive and one negative. Well, if I do that, and I make that positive and that negative, I'm not going to get that difference of 13 that I want. So that's not going to work. So we have to use 5 and 2. So let's try 2 and let's try 5. So 2 times 3b. And yeah, let's do it that way. So 3b times 5 gives me 15b. And 2 times b gives me 2b. Now I can get the difference of 13 there if I make this negative and that positive. So that means I have to have a negative 5 and a positive 2 there. That is a very convoluted way of factoring that one. There you go. All right, 6m squared, 21m, and 9. All right, there is a GCF here. It's going to be 3. So let's start by factoring that out. Now there's only one way to get 2m squared, and that's got to be 2m and m. And there's only one way to get 3, this last term, right? It's got to be 1 and 3. So let's put them in there, and I need it to be, see how this middle term needs to be negative, but this one needs to be positive. So that leads me to believe that they're both going to be negative. And we just check. Okay, 2m and m, negative 1, negative 3. Okay, so that gives me negative 6m, that gives me negative m. Good to go. The last one here, so close to having a GCF, but no, so we're stuck with just trying to factor it. All right, so we could do 4d times d, we could do 2d, 2d. Now I like to start with the ones that are closest together to begin with. All right, now 9 could be 9 and 1, 3 and 3. Well, let's go 2d, 2d. I'm just going to make a little chart here. So 9 could be 1 times 9 or 3 times 3. Now generally I like to start with the ones closest together, so 3 and 3. So if you multiply, you're going to get 6d and 6d. Well, 6d plus 6d does not give me my 20d. So that means I need to try something different. We need to do the 1 and 9. So 2d times 9 is 18d, and 2d times 1 is 2d. Perfect. So let's put in our 9 and 1. Everything's positive, so we're good to go. And I'm just going to clean that up a little bit. Our last one here, 2n squared minus 13n plus 20. All right, well, there's only one way to get 2n squared, 2n and n. 20, we've got options. We've got 1 and 20, 4 and 5, 2 and 10. I like to start with the ones that are closest together. So 4 times 5. So let's just plug in 4 and 5 here. And if you look at your outer product, 2n times 5 gives me 10n. And my inner product gives me 4n. Well, there's no way I'm getting negative 13 using 10 and 4. So we have to go, you could you could switch your 5 and your 4. So 2n times 4 is your outer product. 8n and then 5n. You do get 13. However, if I need to get this middle term negative and the last one positive, that needs to be both negative. And it looks like we're good to go. Check your outer product again. That gives me negative 8n. And my inner product gives me negative 5n. In total, that's negative 13n, and negative 5 times negative 4 gives me positive 20. So I'm good to go. Clean that up a little bit. There's tons of videos on factoring on the internet. This is just one quick review. All right, we have a couple specific situations. Anytime you see two terms with a negative, this clues me in that this is going to be a difference of squares question. And what that means is a difference of squares. Well, a square number, if you think of just what square numbers are, like 1 times 1 is 1 squared, 2 times 2 is 2 squared, 3 times 3 is 3 squared. Okay, well that's what square means. And I'll explain the difference part in a second. But first we have a GCF. So if you factor that out, you get this situation. Now, if we look at d squared, there's only one way to get d squared, and that's d times d. Now, the only way to not have a middle term is for the the last digit of each term here to be the same. And because they need to multiply to get to 4, it's got to be 2 and 2. Make one positive, make one negative, and you're done. Okay, if you expand this, well, let's just expand this one over here. I'm going to forget about the 25 for a second. Just the d plus 2, d minus 2. So d squared minus 2d plus 2d minus 4. Well, this negative and positive are a zero pair. So they disappear. Okay. The difference of squares, the meaning difference is addition and subtraction. All right. And 1 is addition, 1 subtraction. So again, 9x squared minus 49 here. Two terms separated by negative. They're both perfect squares. This has to be a difference of squares question. Now, 9x squared, 3x and 3x, and 49's got to be 7 and 7. Make one positive, make one negative. Done. The last one here, 4t squared plus 11t plus 6. No GCF, so we are stuck going for it. So 4t squared could be 4t times t or 2t times 2t. Okay. And 6, the last term 6 could be 1 and 6 or 2 and 3. Now generally I like to start with the ones that are closest together. All right, 2t and 2t. Everything's positive, so it has to be all positive here. So 2t, 2t, and if we go 1 and 6, all right. Well, your outer product is going to be 12t, and your inner product is 2t. Well, there's no way I'm getting to 11t using 12t and 2t, so no good. And if I swap those numbers, I end up in the exact same situation because both first terms are 2t and 2t. So let's try 2 and 3. So check your outer product. 2t times 3 is 6t. Check your inner product. 4t, there's no way I'm getting to 11t using 6t and 4t. So no bueno. So we've tried all the different variations of 2t and 2t, and it didn't work. So we need to go to 4t and t. All right, let's try 2 and 3. And again, everything has to be positive because everything's positive in the original. Check your outer product. 4t times 3 is 12t, and 2 times t is 2t. Well, there's no way I'm getting to 11 using 12 and 2. So let's swap those around. Which way did I have it? 2 and 3. So let's try 3 and 2. 4t times 2 is 8t, and 3t. Aha, we finally found a way to get 11. So that has to be correct.